Hello and welcome to this lesson about solutions to equations. The learning target for this video is determining if a value for a variable is a solution to an equation. So first, let's talk about variables, expressions, and equations. So a variable is simply a letter or symbol that represents a number. So a letter or symbol that represents a number. And there's several different applications of a variable and different sort of purposes we can use them for. And what we're going to start to see is there's a fine line in the sand between an expression and an equation. So here's our line in the sand, and here's an expression. And on the other side is we have an equation. And so there's a difference here. With an expression, there is no equal sign. You have something like x plus 2. But with an equation, you do have an equal sign. And so we have x plus 2 equals 4. And so this changes the role of a variable. So with an expression, a variable can be any number. So x can be any number. And it's just standing in. So we might say let x be 3, let x be negative 10, let x be 102. And we can plug in those values for x, and then we can evaluate the expression. But now that we have an equal sign right here, x can only be certain numbers. And I put numbers plural with like the s in parentheses there because for an equation it can only be one number, but as you progress to more complicated equations, occasionally you can get multiple answers, and that's something for later down the road. Or if we're talking about an inequality, it could be again multiple numbers, but with an equation it can only really be a specific number. And so that's that's the difference we have now with an equation. We can't plug whatever we want into x. We can only put in a couple of things, if that, for x to make the statement true. And so that's the next thing we have to talk about, is that with expressions, we're not so concerned with something being valid / true. Because with that equal sign, it's more just about evaluating. You're putting a number in and you're crunching the numbers. But because you have an equal sign, is we need this to be valid or true on this side. So, for example, can continue to look at the ones we have. Let's let x equal 3. Well, what we would do to evaluate the expression is go 3 plus 2, which equals 5. You'd box 5. That's the answer because we're evaluating. We're not too concerned about anything being valid or true without sort of being a question. But now we go to an equation, we're going to go to this idea valid or true. And so again, we let x equal 3. We put 3 in. We'll have 3 plus 2 equals 4. We get 5 equals 4. And that is not true. That is not valid. So x cannot equal 3. And so theoretically, this is the difference between an expression and an equation. The role of the variable fundamentally changes. And I have a pretty cool analogy, I think, for this, and it helps kind of make sense of this. So if we're talking about expressions, usually when I talk about expressions, I like to say, hey, think about a variable like this. Forgive the drawing, all right? I'm not an artist. I'm a math teacher. All right, that is a limo. Now, I want you to think of, a limo and think of like a red carpet premiere type thing where you got a bunch of, paparazzi / photographers, and they want to see some fancy celebrities come on out. And if you go to like an award show, at the beginning of this, whoever comes out of this is completely unknown. And it could be anyone. And so that's the thing with expressions, is that the variable can be any one or anything. So any one slash anything. Anyone can come out of that limo at the beginning of the award show. But at the end, we get to equations. And here I'm going to use colors to kind of help make sense of this. I'm going to draw several different limos. We have the blue limo. Again, forgive the art. I'm a math teacher, not an artist. All right, not bad. We have the yellow limo. And I'm going to squeeze one in here. We got the little red, we'll just call it like a fancy car right there for the red one. All right, and the thing is, whoever came out of the yellow limo needs to go back to the yellow limo at the end of the show. They can't go into the blue one like that. No, that's not allowed. Same thing. The person who came out of the blue limo needs to go back to the blue limo. And the person who came out of the red limo needs to go back to the red limo. They can't intermingle. They can't go to other people's cars because those aren't their cars. That's not where their stuff is. And that's not the car they paid for. So they need to go back to theirs. And that's analogous to now X needs to be something. So the variable can only be one thing, or has to be a certain set of things. You can't mix and mingle like you did here. Here it's a big mystery. It could be anyone, it could be anyone or anything. Down here it has to be one thing. They have to go back to their limo because that's just how the whole limo rental thing works. All right, now enough of the theory. Let's talk about some examples. Let's say we have an equation, x plus 5 is equal to 8. And the question is, could be something like this. All right, is 3 a solution to this equation? And so what we do is we'll take our 3, we plug it into x, and we evaluate. And we're going to use one of my favorite mathematical symbols. So we'll put 3 in for x, use parentheses. This one, not too complicated, but they will get more complicated. Equals 8, but my favorite mathematical symbol is the equal sign with a question mark above it, because that's really what's going on. When we ask, is 3 a solution, we're wondering, are these equal to each other? And so we get 8 equals 8, check. The answer is yes, it is a solution. Let's do a few more examples. Let's say 2 is 3x plus 9 is equal to 25. And now the question is 6 a solution? So what we'll do is we'll take 6, plug it into x, so here the parentheses come in handy. And here we also get to see how math is truly building upon itself, because before this, we focused just on this part of the problem, doing 3x plus, or 3 times 6 plus 9. Can you compute that with order of operations? And then, yeah, we did 3x plus 9, let x equal 6. And now we're taking up a notch to where we're seeing, whether or not this is actually a solution to 25. And so we'll get 18 plus 9. And then again, it's the equal sign with the question mark. Not an official symbol, but it's one I like to use a lot for a situation like this. 27 equal 25? Nope. And so x equaling 6 is not a solution. So not a solution. And then let's just do one more, and let's throw in some negative signs to make it a little more complicated here. So let's say we have negative 4x plus 10 is equal to negative 24. And the question is 8 a solution? All right, so what we're going to do, negative 4 times 8 plus 10 equals, with a question mark above it, negative 24. And so, accidentally, I thought it was going to be negative 8 there. It's just regular 8. Negative 32 plus 10 equaling negative 24. Crunch those numbers. That's going to give us negative 22 equals negative 24. Again, it's close, but it's not exact. So the answer here is no, not a solution. And so the big thing again, I really want to stress here with this lesson in this video is, are we taking a value, or do we have a value that is actually a solution? It makes the equation true. Up here, this equation was true when we put 3 in. And so that's true, it's valid, it's a solution. Here, not a solution because it was not true, was not valid. And so that's how this process works. Because eventually we're going to continue to expand upon this idea, and we're going to work on how do you find the exact solution. And then this idea of if something's a solution or not is something that will pop up again when you look at inequalities, or when you look at systems of equations, or you look at two variable equations. So just having a good fundamental understanding of what this is setting us up for success later down the road. So good luck with your practice or homework, and let me know if you have any questions.